mass balance problems, blended component. In this example, we will review the definitions of the limiting reactant, excess of the reactant, and the extent of the reaction. Oxidation of ethylene to ethylene oxide follows the reaction. 2 moles of C2H4 ethylene plus 1 mole of the oxygen would produce 2 moles of ethylene oxide, C2H4O. The feed to the reactor contains 100 kmols of oxygen and 100 kmols of ethylene. Which reactant is a limiting one? What is the percent excess of the reactant? How much ethylene oxide will be produced? And what is the extent of the reaction? We start our solution with balancing chemical reaction. In fact, this reaction is balanced. 2 moles of ethylene would react with 1 mole of oxygen, and the product would be 2 moles of ethylene oxide. Experimental data shows that we have 100 kmols of ethylene and 100 kmols of the oxygen. Looking at the stoichiometry, if we have 100 kmols of ethylene, we need half of that quantity of oxygen, because 2 moles of ethylene would require 1 mole of oxygen. So based on the stoichiometric equation, for 100 kmols of C2H4, we need only 50 kmols of the oxygen. Which reactant is the limiting one? So for 100 kmols of ethylene, we look at how much product we can form. We can form 100 kmols of the ethylene oxide. And the second calculation, if we take 100 kmols of the oxygen, the second reactant, we should produce 200 kmols of the oxygen. Looking at these two numbers, the first one is lower than the second one. Therefore, the ethylene C2H4 is the limiting reactant. What is the fractional excess of the oxygen? We know that the ethylene is the limiting reactant, so the oxygen would be reactant in excess. Based on the definition of the fractional excess, we have the ratio of the number of moles of the oxygen fed into the reactor minus number of moles that we require from the balanced stoichiometric equation, divided by the number of moles from the balanced stoichiometric equation. So 100 experimental feed minus 50 stoichiometry divided by 50 times 100% would give us 100% excess. So we have 100% excess of oxygen going into the reactor. The next question, how much ethylene oxide, how much product will be formed? So if we take 100 kmols of the ethylene, which is obviously the limiting reactant, based on the stoichiometric equations, we will make 100 kmols of ethylene oxide, which would be our product. What would be the extent of this reaction? We know that we have 50 kmols of the oxygen coming out of the process, so for 100 kmols of C2H4, we will make 100 kmols of the ethylene oxide, and because O2 is in excess, we have 50 kmols of O2 coming out of the reactor. So based on the definition of the extent of the reaction, we have number of moles of the oxygen coming out, which is 50 kmols, is equal to initial feed of oxygen into the reactor, and in this case it is 100 kmols, minus the extent. The minus sign is coming out from oxygen, and the oxygen is on the left hand side of the equation, which is an reactant. Therefore we have to have the minus sign, and we have only one extent because we have 1 mole of, or 1 kmol of oxygen going into the reaction based on the stoichiometry. So 50 is equal 100 minus the extent, therefore the extent of the reaction is equal to 50 kmols.